subscribers, welcome. Slightly different from recent streams tonight. We're going to be kicking off with a tutorial on part configs. We're going to be starting from the very beginning, and this is going to be aimed at beginners and upwards. You don't need any special programming skills, you don't need any special software. All you need is be able to type. Hopefully most of you can do that. So, when I say special software, you can use any text-based editor. By text-based editor, I mean things like Notepad, WordPad. You can use Microsoft Word, you can use OpenOffice Writer, you can use Vi, Vim, Emacs, whatever. If you can type on it, you can probably use it. Just bear with me a second. The cat's doing an impression of the Leaning Tower again. There we go. Ba-doing. So, what is a config file? Or a CFG file in short? Basically, they contain parameters for configuration. I told you, we're starting from the beginning. Now, some config files may not be legible without special software. The ones from KSP are quite legible and very easy to understand. All you have to do is have a little bit of guidance. And I've just noticed, I think the on-screen chat is misbehaving. Yes, it is. Let me go and correct that before I kick off again. Chat. Where are you? There you are. Reload. When that white writing starts to disappear, if someone will test it for me, and hopefully it will start putting text on screen. So for this we are going to be looking at files to begin with. Don't worry, we'll be doing some more IKD stuff after we finish this. So here we are looking at KSP's root directory. You can probably see it better if I set it to, no, not extra large icons, large ones. There we go. Straight away you can see config file, config file, config file. And they can be changed. We have that one, which is the part database config file. You've got the physics config file. If you ever wanted to change something to do with KSP's physics, you can go and edit that file. I wouldn't recommend it for beginners though. So it's not actually covered in this tutorial. And that one there is the settings config. It contains all the settings stuff within KSP's menus. Again, we're not looking to those types of config file. What we are looking for is the part config files. This is my 104 stock install. I have lots of installs. So we're going to go into game data. So the only directory in here, because it is stock, is squad. So let's go into squad. As you can see, some more directories in here. I have one here called parts. Let's go into that. And here we have aero, command, compound parts, electrical, engine, fuel tank, miscellaneous, resources, science, structural, thermal, utility, wheel. They don't quite match the categories within the game, but it's close. Let's take a look at fuel tanks. Here we go, various assortments of fuel tanks. The file names here do not necessarily have the same name as the name of the part within the game. So bear that one in mind. Let's go into, say, fuel tank X200-8, and you'll notice a few files in here. Now there may be a few different files, excuse me, files of different names, etc. But we have the config file there. Let me make it a little bit bigger for you guys. There we go. The config file there. We have a model.mu. That is literally a 3D model file. And these two here are DDS files. Those two are textures. I have a tutorial already in my highlights for editing DDS textures, those that are interested. Today we're looking at part configs. Now, this config is associated with Notepad, you can tell by the icon here. However, I have Notepad++ installed, and I use Notepad++ for editing configs for the simple reason being it gives me a few extra features that are quite handy. So I'm going to be using Notepad++. Now, Notepad++ is free. You can download it to your heart's content and use it. So feel free. It recognizes the syntax of a lot of file formats and makes writing and rewriting some of this stuff a lot easier. So I'm going to edit with Notepad++. Now, Notepad++ has a few features. We have various windows across the top. These are different files. So I'm working on several files at any one given time. So I will have multiple windows, and as soon as I open Notepad++, it will reopen those files for me, which makes life so much easier. Especially with KSP's 1001 file format. So we're going to start right at the top. Beginner's level. It's relatively simple and straightforward. All part configs start with hard, all in capitals. Probably not case sensitive, but to be honest, just to make sure you are compatible with Linux users, I suggest making it all in capitals. And then there's going to be an open curly bracket here. Not a square bracket, it's not a circular bracket, it's the squiggly bracket. On most standard QWERTY keyboards, if you hold down shift while hitting the key for a square bracket, you'll get the squiggly bracket. So first parameter is name. Almost everything within these configs are going to be parameter, then an equals, then a value of some sort. So in this case, name. This is the part's internal name to KSP. The only time when you see this name is on the F3 menu, or the same menu that comes up if your craft is just completely destroyed. So it's a text-based value. I would stay away from forward slashes, quotes, commas, full stops, stuff like that. Dashes, yes. Don't use underscores, it's not advisable. But basically, capitals, lowercase, numbers, a dash, and you're good to go. I think that pretty much helps anyone out. Module. For part-based configs, module will always be part. Author. Well, as a general rule, you put down the model author in that section. However, you can put your own name should you wish. Mesh. Now, there's different ways of linking. What is the cat doing? Hang on. Let me reset this. I'm sat in a different position. That's why the cat's having a frib. There we go. Let's try that. So, you've got mesh equals and model equals. There are two different parameters for loading, well, linking to the 3D model file. So this one uses the old standard. Bear with me, I need to rearrange my screens. This one uses the old standard of mesh equals. So it's simply model.mu or fueltank.mu or engine.mu. The model file, the mu file, has to be located in the same directory as the config. You cannot put any pathing here. I haven't been talked about. Oh, that's why. However, if you're using model equals, then you can put a relative path in. Well, it's half relative, half absolute. It is referenced from the charming million. It's relative from the game data directory forward. Wherever the user has put the game on their PC, from the game data directory onwards is the absolute part. Rescale factor. Now you might have scale factor and rescale factor, or scale. Don't get these three mixed up. Rescale will rescale everything. If you wanted to take, say, an orange tank from 2.5 meter to 5 meter, Oak Tree, you wonderful person, thank you very much for the host. Guys that are coming over from Oak Tree's channel, we are doing a tutorial on part config files for beginners. So we are going through everything from the ground up. You don't need any special programming skills, you can do it with Notepad. Good evening Uber, good evening Ventus, good evening Mel, who else? Alijundo, good evening. So, after I've done this tutorial, I will be continuing my asteroid, well, Class E asteroid hilarity with IKD. That's the Insane Colonization Division. Amstrat, thank you for the follow whenever it comes up. So this tutorial will be highlighted on my stream for anyone that wishes to use it as reference. Maybe you find a part config that you like. Cobra 13, thank you for the follow. Yes, I know it ended up being the wrong way around. Oh, hang on, give me a second. I'm dropping frames here. There we go, it's being behaved now. So, rescale factor will rescale everything in one go for you. All the nodes, the model, everything. The which is always wonderful. However, scale changes the scaling of the model only. So you might see that tweaked a few times in part configs. I would suggest leave it alone, unless you know about 3D modeling. Most people, including me, will be using the rescale factor. So it's obviously a number, so I wouldn't recommend using a rescale factor of 0. I'm not quite sure what KSP would actually do, but anything above 0.1 it should be fine. And yes, you can go to a rescale factor of 100 if you wanted something 100 times bigger. Ventus, Twitch alerts is always slower than my bot, because it wasn't made by me. Right, node stacks, and well, basically node underscore. When you are putting parts together within the editor, then you will notice these green blobs. These are nodes, attached nodes. Now these allow you to vertically stack parts together, and they are controlled by things like node stack, and then you've got top, bottom, left, right, up and down. Well, there's a few more, but that's getting complicated. Don't confuse them with node attach. You've got 7 values here. Some part configs only have 6. Don't worry about it. My recommendation is, if they only have 6, put a comma 1 at the end. Then it won't confuse you. So you start with the X coordinate. This is the position of the node. You have the X coordinate, the Y coordinate, and the Z coordinate. The next 3 are the node direction. One of the things that was implemented in KSP 1.0 was node directions. Previously, the node could be attached up, down, left, right. It didn't matter. You could attach it the opposite way around and it wouldn't care. In KSP 1.0, the nodes now have a direction, so they will only allow you to connect 2 nodes together, provided their directions are opposite to each other. So a lot of mods were instantly broken, because these values, these 3 values here, all had positive values, even for node stack bottom. If you look here, the node stack bottom has a negative value here. Ian Loams, thank you for the follow. So node stack top, generally speaking, is a positive for the direction, and node stack bottom is negative. How can you tell? You can work it out from the coordinates. If your node stack top is positive in the numbers relative to on the y-axis, if that is positive, then your direction for the node also needs to be positive. Likewise for the bottom, if it is negative, then it should also be negative. That is a rough general rule. It is not an absolute. I have come across some parts that do not conform to that convention, but they are more advanced parts, and well, by the time you get to that point, you should be well versed in it. Question from Amstrat: what is the difference between a top, bottom and up down node stack? As a general rule, according to the game, none. It's just a name. However, the convention is that top, bottom are nodes that are in the Y axis. Right, up and down are the X axis. I think I got that the right way around. And left and right are the ones in the Z axis by convention. But KSP really doesn't care that much. It's just a node name. Likewise, you can also see on some configs that have multiple nodes, say on the bottom here, you'll find 01 at the end and 02 and basically a number. Now, the number at the end of the node stack is the node size. So the size of the green blob. So this can go from 1 up to 5, I believe, but 5 is absolutely massive. So as a general rule, well, a kind of convention, I suppose, 1.25 meters and below should be 1, 2.5 and 3.7 should be 2, and 5 and above, well, on the rare occasions that you actually going to be using them, should be 3, 4 and 5. Although, to be honest, once you get to 4, that's a really big green blob. So, as a general rule, if I'm creating something really big, I just use size 3. Because otherwise, if you're attaching something that's size 1 to it, your green blob is quite often bigger than the part. It gets annoying. Next one is node attach. Don't confuse this with node stacks. It has nothing to do with stacking nodes. Node attach is when you surface attach one part onto another part, it tells KSP how far away from the part to surface attach to it and in what orientation. So if you've ever had a part that when you stack it everything's fine, but when you surface attach it, it's halfway inside of another part, that is because this value is configured wrong. Basically it's called, well, I call it the attach mesh for simplicity for everybody, but it's kind of not really, but it's a technical inaccuracy, so I kind of ignore that. So what you're doing is telling it what orientation this part goes in when you try to surface attach it onto something else, and you also tell it how far away from the part to attach it. So if you've got a part that's 1 meter long, without this value, or if this value was all zeros, it would start attaching it with the part halfway inside the other. Which, while that can produce some interesting results, quite often people don't want it. And besides, you also have the position adjust within the KSP editors now. So you might as well save most people a heck of a lot of time and configure this properly. So again, X coordinate, Y coordinate, Z coordinate, and then you'll have 3 directions along the X, Y and Z again. Now this one has a 1 at the end. As a general rule, leave it as 1. I've never seen a node attach config with 2, 3, 4 or 5 at the end of it. I've seen configs without at 1, i.e. with 6 numbers, not 7. That's fine, it'll just default to 1. So don't start panicking if your part config only has 6 numbers. Tech required. This is for career and science modes. It's the bit that attaches the part into the category on the tech tree. So it means that you need that technology unlocked before you can see the part. Entry cost. This is the cost to unlock the part if you are in hard difficulty, I believe it is, where you have to pay to unlock a part. This has nothing to do with purchasing the part. This is a one-off cost. The cost equals is the cost to put the part on your rocket. Don't get those two mixed up. Category. This is the category to put the part in the editor on the left hand side. So you'll have this one which is set to fuel tanks. You could have the one for command pods, the one for control, aerodynamics, so on and so forth. However, setting this to any other category that doesn't exist will make the part disappear. But you'll still have it on your craft, so it'll only disappear from the editor. There was an issue a while ago where there was a couple of mods that had module manager patches that hid parts from other people's mods if they existed. I suggest you don't do this. You will get jumped on by the rest of the community. So always have proper categories for everything, and don't try to hide somebody else's part. Subcategory. One of the things that Squad was trying to do, or was looking at doing, was to have the subcategories within the main category. However, this seems to have fallen on the wayside, or at least they haven't implemented it in the last 18 months at least. I think it's 18 months ago since they suggested it. Something like that. So this should always be 0. At least for the time being. Title. This is what you see in the editor. This is the title of the part. Again, it is characters, numbers, dashes. Yes, don't use quotes, don't use forward slashes or backslashes or hashes or ats. The game might appear to accept them for you, but somebody else could load it and it would cause problems. So my advice, don't do it. Manufacturer, again, more text. This is the manufacturer that you see within the editor. So literally you could put your own name there, which for all the parts that I'm currently editing for my mod, they all say CW Tech. Description, again, it's in the editor box, the description. So more text, same rules as before. Attach rules. Now they're not actually listed in this part config. Don't you just love that? But quite a lot of parts actually tell you what the parameters are. Take a quick look. Have a look at the T100. Nope, that's not got it. Have a look at the size 3 large tank. Nope, that's not good at it either. Typical. The attach rules are quite simple. They dictate how you can attach. Actually, I think I know of one. Oh, sugars. I don't want to do that. Nope, not that one. No, even some of mine haven't got them. That's interesting. Oh, there we go. They dictate how you can attach parts. So, it's always 5 numbers. These 5 numbers are separated by a comma, and they are either 0 or 1. No other value. So first of all, stack. Is this part allowed to be stack attached to another part? That is, stack attached is with the nodes, the green blobs. 0 for no, 1 for yes. In this case, yes it is. Does this part surface, or can this part surface attach to another part? 0 for no, 1 for yes. In this case, this one, yes, it allows it to be surface attached. Third value, does this part allow another part to be stack attached to it? 0 for no, 1 for yes. The fourth value is, does this part allow you to surface attach another part to it? Ventus, what magic? Oh, that's done on purpose. What was I up to? Oh yes. So, does it allow another part to be surface attached to it? The last value is allow collision. This is basically part collisions within the same vessel. Basically, if you wanted to cause people massive headaches and make them not clip your part into something else, then set that to 1. Yeah, I'm not going to go there. I would advise always setting it to 0, otherwise you'll cause a massive headache for people. Next values. Mass equals. This is the mass of the item. This is the dry mass. This does not include the mass of any resources that you add into it. So this is just the framework only. And the value is a number only, which can be a decimal. And the value is in tons. Drag model type. Now you will come across a handful of parts, relatively speaking, that will have something different than default. If they have something different from default, leave it alone, because that dictates how the drag modeling works within the part. It's extremely complicated, and even I don't mess with that. Leave it alone or set it to default. Minimum drag, maximum drag. This is actually a ratio of sorts, best way of putting it, and it allows you to limit how much or how little the game will automatically apply drag to your part. As a general rule, most parts that I come across are 0.2 for minimum and maximum. Not all of them. Sometimes you can make a particularly awkward part. For example, if you're setting somebody a challenge, starts whistling, you can create a part that is so aerodynamically draggy that they would never get it out of Kerbin's atmosphere. Even my rockets would never get it out. Not that I would ever do such a thing, honest. And I certainly wouldn't set a challenge for people and say, can you get this 100-ton part into orbit without hyper editing it? And just not tell people that I have been light fingered on the config values. I certainly wouldn't do that. Next one is angular drag. This kind of depends on the dimensions of your model. However, as a rough guide, this value is 10 times the maximum drag as a rough guide. Basically, if your part is rectangular or singular, or cylindrical rather, you want it approximately 10 times, because the aerodynamics, when it rotates round, so it's going side on into the airflow, right, you would expect it to present a bigger surface for the air and thus more drag. So most people have it at about 10 times. Again, if you wanted to create a part that is seriously unstable in the atmosphere, you can set it to a significantly lower atmosphere drag ratio. And I certainly would not set a challenge with a yeah, you get the idea. Crash tolerance. This is the tolerance of the part when impacting with either the ground, an asteroid, another part, whatever. And it's a number, and it's in meters per second. So if you wanted for example, a pod that you could come back to Kerbin at interplanetary speeds and land on the surface without parachutes, set that number to an insanely high number, like 200, 300, something like that. And it'll just go thunk into the ground and, well, it may well bounce. But most parts are realistic and keep them around about 10 meters per second, something like that. Braking force and braking torque. These are basically for the nodes, i.e. the connections between parts, and those two dictate how much torque or force it will take to snap two parts apart. So the bigger the physical size of your model is, the more you've got to jack those up. Otherwise it will just poof like kindling. Cover with shades. with a category of 4. There used to be a standard where it had numbers in for categories a long time ago. So it would just select the 4th category from the list, which would be, well, the 4th one down is structural, I think, off the top of my head. Yes, I think it's structural. But I think it would have gone into there. But it all just depends on the internal workings in KSP. I'm not quite sure of the numbering off the top of my head, but that is an old system and might have been phased out by now. Pods are usually 70 meters per second. Are they? Really? Darn, I need to change my cockpits then. My cockpits are 15, I think. Or maybe 20. Oh, it might be under control then, Girl with Shades. Yes, because you've got pods, then you've got tanks, then you've got engines, and then you've got control. So yeah, control will be number 4. Going down the list. So, a lot of people that are now running Kerbal Joint Reinforcement will be doing so because parts are snapping off far too easily. This is mainly a thing for bigger parts, like the Mark III fuselage parts. The bigger the part that you have, the higher braking force and braking torque needs to be. So if you're designing a part that is 10 meters by 10 meters by 3 meters, you're going to need a pretty big value in there, both of them. Max temp, this is the maximum temperature in Kelvin, and this temperature is the maximum temperature both internally and surface. And if the temperature internally or surface exceeds this, then the part goes bang and disappears. So, not that I would ever condone cheating, but if you wanted a part that was indestructible for re-entry, you could set this to a seriously high number. Or if you wanted a part that was very weak and as soon as you touch the atmosphere it goes bang, you can set that to a low number. Now, 3 config values here that are brand new since KSP introduced heating. That is thermal mass modifier, emissive constant, and heat conductivity. Starting with the top. Thermal mass modifier is a modification ratio to its mass. When it is feeding into the calculations for temperature rise or fall. So what you have in physics is it takes so much power to X amount of power to increase the part's temperature by 1 degree, and that is what's called specific heat or specific heat capacity. That ratio that's highlighted changes the specific heat capacity by whatever this value is. So in this case it's 5 times. Yes, Ventus, I kind of go for realism. So emissive constant. Every part, whether it's in an atmosphere or in space, or even landed in a liquid body, water for example, emits heat. It will give it up. It will radiate it out into space. It will allow any airflow going over it to take heat away. This value here allows you to modify how much heat is lost in those manners. So in this case, it's twice as much as what KSP tries to calculate it. It allows you to tailor parts such as heat sinks, or parts that have heat sinks built into them. Hint hint. Heat conductivity. This is a ratio that allows you to conduct heat from one part to another. Setting that to a very high value for parts connected to engines is probably going to be a bad idea. It will conduct a lot of heat from the engine straight into your craft. And go with shades. Yes, it was. And basically any parts with a lower maximum temperature could just simply blow up just by launching it. So be aware of this. Now, there may be a few other parameters in there that are specific to certain types of parts. We'll be going over the variations shortly. After you've got those standard configs and parameters, you get modules. Now, these are basically sections of the config, and they point to modules that are either stock or provided by a mod DLL. So for example, this says module, and that tells the game that I want to load a module for this part, and I'm going to give it config parameters. So module, and then open squiggly brackets. Where have we seen that before? Oh yes, it's right at the start of the file. So then you've got name equals. This is the module name. In this particular one, it's module engines, because we're still on my plasma impulse engine. So this is loading the engine module. If we go to a fuel tank, there is no module config. Because fuel tanks are fuel tanks. Now, some tanks may have configuration for things like modular fuels or interstellar fuel switch, stuff like that. They might have them already built in. Just because a module is defined in here in the config doesn't mean it exists. Be aware of that. Let's skip modules for a moment and come back to it. Don't worry, just for a moment. Resource, again, we've seen this style before with the squiggly brackets. Basically says, I want to add a resource capability to this part. And here it says the name equals liquid fuel. I want the amount this much within the part, so that's the starting amount that the part starts with. And this here is the maximum amount. So you can start off with a part that has nothing in there but has a maximum amount of whatever, so you can fill it up. You can of course have multiple resources defined per part. If you wanted to add a resource, all you do is highlight, copy, go down to here, the close squiggly brackets, hit enter for a new line, and right click, paste. And then you give it a name. For example, if you wanted to add monoprop to your tanks, then you've got monoprop amount and max amount. And hey presto, you've now got a tank that's got liquid fuel, oxidizer and monoprop in it. Likewise, if you wanted one of your tanks to also be a battery, then you can change this resource to electric charge, and it will then function as a battery for you. Give me a moment, I need a drink. Okay, so quick recap is we've just shown you how to set the node stacking properly. I've done a brief overview at least anyway. So if you come across a part that is pre 1.0 and therefore has issues with the node stack direction, you can actually go and change it yourselves. Also showing you how to manually rescale a part, the rescale factor. So you don't need tweak scale installed, you can manually rescale the model. Also showing you how to change the part's name as you see it, and the manufacturer and the description. Feel free to be creative. Showing you how to change the drag setup and the amount of torque to brake parts, as well as its maximum temperature. One part that this has, which is brand new to KSP 1.0, is bulkhead profiles. There isn't a lot of information that I've found so far. Having said that, anything within the last about 2 weeks or so, I could prove me wrong. But as a general rule, it doesn't really make much difference if you don't include it. But if it's there, there's probably nothing really to be gained by changing it. Cable with Shades, I already have a link to the CFG wiki. It's in my profile. I'm not quite there yet. So, Jedbo. I'll re-explain nodes at the end of the tutorial, since we've already been through it, because this is going to get highlighted on my page. So I'll come back to it just for you. So let's go to Modules. Module engine is probably one that may interest a lot of people, but it's also kind of difficult to explain for beginners. So here goes. First of all, if you're loading the engine module, you'll have name equals module engines. If your engine has a gimbal on it, then you will have the thrust vector transform name, and this is a parameter within the model itself. Setting this to some arbitrary value isn't going to help you. It's not going to work. So that name there matches a tag within the model itself, within the model file. Exhaust damage. Does the exhaust do damage to other parts if they cross over the exhaust? True or false? Ignition threshold. This is the percentage, well, the decimal percentage of throttle before the engine will actually ignite. So this one, 0.01, is 1% throttle. So it's 1/100th of the throttle in percentage. So it's a value between 0 and 1. Minimum thrust and maximum thrust are quite literally as they sound, the minimum and maximum thrust. This is in kilonewtons. So you can set the max thrust quite high if you wanted to. Heat production, this is kind of a awkward area because Squad, I think, are still going to be tweaking this on engines, although I could be wrong, so don't quote me on that. But it's either a set amount up to 100% or it's a rescale value. I believe it's going to be kept as a max amount. They were toying with it last time we heard stuff about the engine heat production. Bear in mind, engines have been producing heat since way before 0.21, but it's only now that that heat can be conducted around the rest of the craft. FX offset. FX is as it sounds, it's the effects of whatever. In this particular case, it's going to be the great big flame out the back of the engine, or flames. You can have multiple, but this is an offset from the bottom of the engine, so some of them will have values in here to move the flame down so that there's a gap. Propellant. Ventus, yes, smoke as well. Flames and smoke. Propellant. You can have quite a few propellants in here. This particular one uses impulse plasma, which is one of my resources, and electric charge. Engines such as the skipper mainsail will have liquid fuel and oxidizer, and they will have the ratios in here of liquid fuel to oxidizer. So liquid fuel is 0.9 and oxidizer is 1.0. This ratio, I recommend adding these ratios add up to the same number of resources. So if you only have one resource, its ratio should add up to 1. If you had 2 resources as propellant, the ratio should add up to 2. If you have 3 resources, then the ratio should add up to 3. That's not always the case though, but well, specifically in mine, because I have some very weird requirements for this particular engine, it was easier for me to set whole numbers. But that's just me. Whether this will stay with those ratios or not, only time will tell. Yes, I like to be different. Atmospheric curve. Oh, this one's a fun one. Everybody that's seen KSP and played KSP 0.9 that then moved on to 1.0, pretty much everybody that builds planes will be whinging to high heaven about the turbofans and all of the jet engines having a maximum ceiling that they can operate at. That is where this comes in. Key equals, you can have multiple values, but this sets a pseudo curve on the basically the ISP of an engine. So first value there, this one, that's a 0, that is the atmospheric pressure. So at no atmosphere, i.e. space, we have an ISP of 9,000. However, as soon as the atmospheric pressure hits 0.01, we have no ISP at all, we get no thrust. And likewise, when it's a 1 bar atmospheric pressure, we still get 0. But again, those squiggly brackets, and then because these are sections within another section, which is allowed, you close that one as well. So one of the features of Notepad is, if I click on one of these squiggly brackets, it will highlight the closing one for me. I can more easily see the syntax. And it also makes it easier for me to explain it as well. Likewise, in the nested ones, you click on it there and it draws a dotted red line between them. Always helpful. One thing to note that I've actually skipped over and that people might be interested in, draw gauge is the little green bar that shows up on your staging while you're in flight on the left hand side. Yes. On a standard liquid fuel and oxidizer engine, draw gauge equals true is only there with fuel. It would not be there for oxidizer. If you wanted the gauge to be there for oxidizer, you can copy draw gauge equals true and paste it in down here. So to demonstrate, right click, copy, go to here, hit enter, right click, paste, and that would then show the second propellant, or third propellant, fourth propellant, whichever. So going down, module, again, it's adding another module to it. So we've got name equals module gimbal. Again, if your engines have gimbal capabilities on them, you will be loading this one, or KM gimbal, or one of the other modded gimbals out there. So again, gimbal transform name is the same one that you've seen up here. The thrust vector. I think in 99.9% of the cases you're going to want them the same. Maybe there are cases that I'm not quite, can't quite think of at the moment where they wouldn't be the same, but still, this is basically the animation of sorts. And gimbal ranges to how much the gimbaling you have in degrees. In this particular case we only have 1 degree of gimbal. Now module name FX module animate throttle is one of the animation built-in stock animation effects for engines. It, for beginners, remember, it basically allows you to vary the amount of flames and smoke produced based on your throttle input. It also allows you to do other things such as emissive light, and it can be configured to move, say, baffles on an engine along with your throttle setting. Well, that's going way too deep. I think I've only seen that set up once. But again, animation name is an internal value within the model itself. Depend on engine state. I'm pretty sure this is a new parameter that they put in, and it's a little bit complicated for beginners, so I would advise not touching it. Basically, it allows you to do some of the more advanced features with engines. That's all I'm going to say. Response speed. This is the speed at which excuse me, the engine can go from 0 to full power. So in this particular case it's half a second. For jet engines you might have 120 seconds to spool up. Most liquid fuel engines are about half a second, maybe a second, whereas things that are rotating, such as turbofans and even propeller-based planes, would have a severely long time. Jedbo. The cat follows my face, and it is doing all sorts of weird things at the moment because I'm actually moving around. Next module is module jettison. This is not for jettisoning the engines. More to the pity. I would love to have a mod like that. Module jettison is when you have a fairing around the engine that automatically puts itself in. Module jettison, as it said, jettison name fairing, right, is the shroud that goes around the engine that's in line with the stack. So some people may see action groups that are defined to jettison. Okay is basically my reply to that. You can launch rockets that way without using separators, and they don't recommend it. But I said don't recommend, and this is for beginners. Intermediates and advanced, go for it. Have fun. Take care. Bottom node name. In some respects, I think it's a really stupid thing that they put this in. However, it allows more flexibility, so I actually like it being in there. But as a general rule, if you have an engine that can have fairings on it, then you will have a node called bottom, and it will be below the engine bell. For an example, is fairing. There are different types of different ways of using module jettison, and the way that most people use it is as a fairing. That will probably be true. Jettisoned object mass is literally as it sounds, the mass of what's being jettisoned. Jettison force is how much force is used to push that part away. Ventus parts can have custom fairings, yes. Whether a particular engine has a custom fairing, I couldn't tell you that one. Jettison direction is which way are these parts jettisoned. Remember, X, Y, Z. And that is reference to the model itself. So that one's a little bit more advanced. So likewise, model, open squiggly brackets, close squiggly brackets, and right at the very end there's the part close. Very important to have a part close in there. You can create problems by not closing the part, because it'll read the end of the file, and that could produce some undesirable effects. Let me revert this config file because this one's one of mine. And let me get rid of that one. So let's have a look at a different type. Let's go for aero. We'll ignore heat shields for the time being. Let's take airliner wings. I'll do. Main wing. Right. Again, straight away, you'll start to recognise this config. You'll recognise its style. Pretty much most of this is the same. The only additional ones here, I think, are explosion potential. This is a risk probability of the thing exploding or just going poof. Fuel cross feed is where the fuel, or should I say resources, can cross feed through the part. True or false, basically. So for this particular one, for this particular part, we actually have a model definition and model equals. Again, As I mentioned at the start, this has a path that starts from the game data directory. No matter where you put KSP on your PC, this path will start from game data. So it's a fixed path, but it's relative to the install. Now, this part is a wing, so it has a module called lifting surface, module lifting surface, and this is what configures it as a wing. So use internal drag module. Use internal drag model. True. This allows you to, well, either use KSP's built-in drag calculations, or if you set it to false, you can add your own in. Way beyond beginners, I recommend leaving it as true. KSP generally isn't too far off. Although, that being said, I have seen some cases where I'm just like, KSP, what the heck are you doing with this part? But anyway. Deflection lift coefficient. This is basically a scale value to scale how much lift is produced when the wing starts to increase its angle of attack. So as you pitch upwards, i.e. pulling back on the stick or pressing S, how much additional lift is created because the plane is angled up relative to the flow of the air. So going with that coefficient also comes the amount of drag at maximum AOA. AOA is angle of attack. That is, as I was just saying, it is the angle of difference between the part when you pitch up or down relative to the flow of the air. Yep, Ventress, I was just gonna come to that. So, drag at maximum angle of attack, there's your value. That then goes into a formula to calculate how fast your plane is gonna slow down with your wings in certain positions. For example, if you stall, for example. Drag at minimum, that is basically with your wing going head straight on into the wind, which actually 0.0 pretty unrealistic, but depends on how you want to look at it. Resource, yes, you can add resources to any part no matter what it is. Whether it's realistic for that part to have that resource or not is entirely up to yourselves. It's your KSP, it's your rules. In this particular case, it's a wing, so it has liquid fuel in it. There's nothing stopping you from copying that, as I've already shown you how to do twice now, and putting in oxidizer, or putting in electric charge, or monoprop, whatever. That's up to you. You can configure it the way any way you like. So going back to what Kerbal with Shades has said with regards to these modules, you can have this module on any part. So for example, module lifting surface does not have to be confined to wings. You can have it on fuselage parts as well, and they can function as a lifting surface, which is actually more realistic, because you have the, which one was it? Is it the X-17? That weird triangular thing? That is a lifting body. Do a Google search on lifting body. I think it was, or was it the X-71? One of them was this really weird thing that actually had no wings, and it was because the body itself is designed as, well, in aerodynamic terms, as a wing, and it produces lift. So you can put this module on anything. How much lift it produces is entirely up to you. Next one is control surfaces. One of the things that annoys me about control surfaces in some respects is how slow they go. Because autopilots like the built-in SAS or MechJeb or any of the others, they will all not be too happy if your control surfaces move too slow. Dream Chaser, is that what it is, Ventus? Right, do a Google search for Dream Chaser then, or even better, a YouTube search. So in or on control surfaces, you'll have the module control surface. Remember, these are all stock modules, by the way. So use internal drag model, same as we explained for lifting surface. Suggest leaving it as true. Drag coefficient depends on your model and how realistic you want to be. Deflection lift coefficient, we've already been through. Control surface range, this is the degrees of motion from the control surface. Control surface area, this is the area in meters squared, I think they did it in meters squared. Basically, how big is this control surface to allow it to move? It's basically in the calculation for deflecting the airflow. There's no mouse grab there. Actuator speed is basically how fast it will move. The faster you make this number, the more instantly it will respond. However, be aware of basically realistic movements, which is why I kind of have a love-hate relationship with control surfaces, because some of them are instant move to maximums, which allows autopilots to control planes properly, and some of them are just transitioning far too slow, and therefore autopilots cannot fly them. because they end up overcompensating and then you end up with flat spins and all sorts. So it's kind of a love-hate relationship for me. Transform name. This is reference to an internal tag within the model. Basically, the transform changes the model. So in this particular case, it rotates it up or down. As a general rule, beginners will not be changing that. If you're changing it and you know you need to, then you're not a beginner. Tail fin. Anything interesting in here? Just bear with me one moment. Okay, I'm back. Sorry about that. So, Kill Shades I've spoiled is a subcategory. Normally I'd answer these questions that have already been over at the end. However, subcategories are something that hasn't been implemented by Squad yet. So they should always be set to 0. It was an idea that Squad could have subcategories within the main categories to allow parts to be easily sorted. However, in the last 18 months or so, they have never implemented it. So on this part, we've got model equals, which is fine. KSP can use either format, as I've already mentioned, and we have the control surface module. Pretty much simple. Nothing spectacularly interesting in here. Let's see if we can find something with a little more fun. Go all the way back, let's go into command. Let's go and take a look at the Mark 1 pod. That one will do. You can see several DDS files. These things are great for editing. If you wanted a bright pink Mark 1 pod, go take a look at my tutorial on DDS texture editing and go to town. So let's have a look at the config file for the Mark 1. Anything in these config files with a double / is a comment. So if you see lines starting with / there, the game ignores them and so can you. They're just for notes, basically. So, pretty much standard. You can keep going down. You may find some have COP offset and COL offset. Off the top of my head, I can never work out what COP was. But COL is center of lift. So, if you have a wing, you can offset where the lift is acted upon. So instead of it being I don't know, the origin of the wing model that is. You can shift it more towards the wing tip or more towards the bigger bit of the wing, something like that. You can even shift it above or below the wing, in front of the wing, behind the wing, stuff like that. I believe I saw somebody with a plane where the centre of lift was so far at the back of the plane he could not, well, presumably he could not get the thing to balance. That may be that the part that he was using needs a centre of lift offset. Ventus, that's entirely possible. So, standard config values, anything new? Anything new? Nope. Vessel type. You can, certainly on things like pods or probes, you can specify the vessel type, so it'll automatically set your icon for you. In this particular case, it's set to ship. You could set it to probe, debris, station, any of them that are along the top of the trekking centre. I wouldn't recommend setting them to asteroid though, or flag, although that could get kind of amusing if done right. Crew capacity. If your part has space for Kerbals inside it, then you'll have crew capacity equals whatever. This is the maximum crew capacity. Internal is a reference to an IVA, i.e. the internals of the cockpit. Not going to go through IVA configs and IVA modelling because that's way beyond the beginner stage. Module command. If it's a command capable part, then you will have this in here, along with the configuration value of minimum crew. This is the minimum number of Kerbals required to be able to control it manually, i.e. via local control. So minimum crew can be less than crew capacity. So in the terms of the Mark 1-3, I think it is, the 3-man pod, its crew capacity is set to 3, but the minimum crew is set to 1. Resource. Again, this has resources defined for it, and it's electric charge, so it has a battery on board. Module. Reaction wheels. If your part is a reaction wheel or can contain a reaction wheel, then this is where it's configured. Pitch, torque, roll torque, pitch, torque, yaw torque and roll torque is defined within these three. That's the amount of kilonewtons of torque to rotate the craft left, right, up, down and roll it around its center axis. Right, where it says resource here, this is the usage, not a definition. So in this particular case, it's saying in order for the reaction wheel to work, it requires electric charge at that rate per second. You can set electric charge to another resource if you wished. Again, resource is closed here, and the module for reaction wheel is closed there. Next module is science experiment. If your parts are intended to be useful in career or science modes, then you need this defining. So module science experiment, experiment ID crew report. You can have others as well. So experiment action name crew report, these are internal names within KSP, so my advice is leave them alone. Reset action name, again internal reference. Review action name, again same again. Use staging. Some of you that are slightly more advanced than beginners may want to play with this. Basically, it allows you to do reports, etc. In your staging. So when you press space, it allows it to. It will actually create an icon to show it up in your staging, which is always hilarious. Let's play Ali. That's all I'm going to say. Anyway, use action groups. This allows you to tether the crew report to an action group. Ventus, nope. Not being secretive about that one. I have seen some very interesting results from modded parts to do with science. And, shall we say, science spam. But that's all I'm going to say. How you configure yours is entirely up to you. Use action groups, which is great. That means you can pick this report off by an action group, so you don't have to click on the pod all the time. Hide user interface when unavailable. Probably want to set that to true. Rerunnable. Basically, as it sounds, can you do the report more than once? Yes or no? XMIC data scaler. So basically, when you generate a report, the report itself has a packet size associated with it. You can adjust that inside your own part, so you can make it bigger or smaller. And that's what that scalar value is. As a general rule, most people probably want to keep it as 1. If you wanted some fun, you can set it to higher or lower. Now, usage required mass internal and external, leave them alone. I have not been able to find a proper reference to what they are. So if I haven't found it, then that would be like way into an advanced tutorial. So for beginners, leave them alone. Next module is module science container. Most people that have played career for a bit and done some orbiting at least and whatnot will know about the science container and doing the science shuffle. That's the module that you want to add. Pretty much everything on there you can leave as it is. You can set it, if you set EVA only storage to false, you can store experiments without having to EVA. Storage range is for EVA and it's in meters. That's how close you have to be to it in order to store the experiment. So next up, resource module. If your model is capable of displaying your flag, then you need that module then. Right. Module. Conduction multiplayer. Oh, how we have fun. This is basically to do with heat conduction. As a general rule, beginners will not want to change this value, so pretty much leave it alone as to whatever it is. However, as a general rule, I said general, if you increase these figures, it will conduct heat faster. What type of heat is another good question. So that's all the stuff for command pods done. Now don't forget other mods such as TAC life support, remote tech, etc. will add stuff to parts by a module manager, but that's kind of getting way above beginner grade, so I'm not going to go into it. So if you have TAC life support, it will look for parts with certain conditions and automatically add life support to that part for you. I think one of the conditions is maximum crew above 0, and it'll automatically put life support in. So if you have a look at the Mark II drone core, take a look. Everything is going to be pretty much standard here. Please note vessel type is probe on this one. Right, this one has the module SAS. Good question on that one. But it does have module command with minimum crew resource 0, which is how probes are actually defined within the game. When you put remote tech in, its module manager config looks for module command with a minimum crew of 0, for example, and then it will add its own modules in automatically. So what else can we see? Some of the science stuff, let's have a look at that. Materials bay. So, taking one look at the part, again, by now should start to be able to see similarities between the configs. They pretty much have more or less the same values except for the bits that I'm pointing out. Ventus, please don't repeat yourself, I have seen you. Some models are able to animate, i.e., for example, solar panels that fold outwards, cargo bays that open, so on and so forth. This module here, Module Animate Generic, is the built-in KSP module for animating models. These values in here will all be relative to the part itself. Specifically that one, the animation name is defined within the model itself. So changing that to an arbitrary value, not going to help you. You're just going to break it. However, start event GUI name is the text that is placed on the screen that people can see. So start event, end event and action GUI name are basically just text that's printed on the stream, on the screen, and that's all they are. That one is the key. Now there are other modules from different mods that will do the same thing, and they work in slightly different ways. As a general rule, leave that module alone. For beginners, that is. Now, module Science Experiment is always interesting because you can do some really funky things with it. So, module Science Experiment. It's a stock module. Experiment ID is an internal name given to specific science experiments. So setting this arbitrarily, it's just going to cause a problem. And it just won't work. Unless you match the IDs. Experiment action name is what's seen from the front end of KSP, what the user sees. Reset action name, same thing. Use staging, nice little feature that they added here that allows you to put science experiments, etc. on staging groups. Use action groups, again as already discussed. I'll just use action groups to kick off that science experiment. Hide user interface when unavailable, set to true. Probably want to leave that set to true. Xmit data scaler we've already been through. FX modules. This is a, well, it basically tells the module science experiment code to animate model. So for example, if you kick this, if you observe the material bay, you can have that set to 1 with a few other parameters and lights could start flashing in the material bay to say it's done and to say it's been used. That can also be linked to module animations as well. Data is collectible. Well, I'm not quite sure what data is not collectible, but you probably want to leave that set to true. Select action name. That is for the graphical interface, what the user sees. Interaction range. That is during IVA. Those two, I have no frigging clue what they are, basically. I haven't found a decent explanation yet for them. So if your part has them on, leave them alone. Oh, come on. That's pretty much a lot of things. Now there are some not so beginnery stuff. So for example, folding radiators that have been introduced in 102, I think, 103, whichever one it is. Again, part config is pretty much the same. However, module deployable radiator is a stock module. Please note this is deployable radiator. These are the ones that fold out and not the one you just slap to the surface of your rocket. Animation name, this is within 1.0. Thanks, Ventus. This is the animation name within the model itself. Retractable. Now you know where to go to look for those solar panels that aren't retractable anymore. True or false. Pivot name. That is a tag within the model itself. Raycast transform name. Not entirely sure what raycast is. It's to do with the model and animations. Again, this value is a tag within the model itself. Anything that's a tag within the model itself, the config should match the model. So don't change it. Wind resistance. Well, this obviously when it's deployed would have air resistance. So that is the value there. Don't believe it is force as such. I think it's more of a ratio for one of the KSP internal calculations. But again, it's that new, there isn't much in the way of documentation on it. Tracking speed, this is how much it will turn. Oh wait, I don't, that was what raycast was. With the deployable radiators, you can have them be edge on to the sun, and raycast is what they called the name for it's a tag within the model itself to indicate the direction of the panel. So with solar panels, this tag will be pointing so it's flat onto the solar panel. With heat exchangers, with radiators, this tag will be moved so that it will be edge on to the sun, so that it will track to the edge facing the sun rather than the flattest part. Next module is the same, well, sort of the same, regardless of whether it's deployable or not, and that is the module active radiator. And this is the maximum energy transfer, and I believe this is in watts, or at least it is as far as I'm aware. Setting this to higher value, will allow your radiators to radiate more heat. Now you can also copy that module and put it onto another part. So there's no reason why this module cannot be on, say, fuel tanks. So that your fuel tanks will actively try to cool the vessel. I said there's no reason why you can't do that. I said nothing about whether it is realistic or not. I'm not having that debate. Good evening, Cantab. Have a quick look in utilities. Docking ports. Right, having a look at the Clampatron Senior. Junior. I thought I said senior then. Everything pretty much the same here, except for this section. Basically, this is the module that sets the part up as a docking port. Its reference attached node matches one of these nodes here. So this here can either be set to top, bottom, left, right, up, down, whatever. You can even have parts that have multiple docking nodes on the same part. All you do is define the node and then point the module at it. So you say module, docking node, top, module, docking node, bottom, module, docking node, left, so on and so forth. Node type, this is very important. A size 0 node cannot be docked to if the docking node is size 1. You can't dock size 1 to size 0. Likewise, you can't dock size 2 to size 1. Nor can you dock size 2 to size 0, so on and so forth. It'd be a bit unrealistic if you could do that, really. So you could set it to size 1000, theoretically, to have your own type of docking ports that only your own part can dock to, until somebody reverse engineers it and makes something to counteract your part. Now there are additional values that can be used to reconfigure docking nodes. For example, the magnetics, you can dial them up or down, but they're a little bit on the advanced side, so I'm not going to cover them in basics. What else can we find? Yep, docking port bugs were reported to Squad over a year ago, and one bug in particular was re-reported by me about a week or two after 1.0 was released, because Squad annoyed me by releasing 1.0 and not fixing the docking port bug. So I re-reported it. Grappling device. Everybody knows about the claw. Claw. So pretty much everything here is standard. Note this one only has a node stack top. which just so happens to be configured as node stack bottom. Who knew? So, module grapple node. So, node transform name is a tag within the model itself. Again, leave it alone. Deploy animation controller. Basically, does your model animate when deployed? Yes or no? 0 or 1. Node type allows you to set the type of grapple, and I believe it's not used, although I could be wrong. Capture range. This is the range that the object, say the asteroid, has to be from the model center before it can consider it captured. Capture minimum forward speed, which anyone that was watching me Saturday evening, I think it was, no, it was before then, yes, it was Saturday evening, would know that I tried to dock at precisely 0.8 meters per second and it just bounced off. Tried to grapple, sorry, not dock, and just bounced off. When I gave it a good shunt at 1 meter per second, it worked. That's where that is defined. Capture maximum relative velocity. Basically, if you try and capture too fast, yeah, you're going to have a problem. That's what that value is for. This particular one is set to 1. So you have between the minimum and the maximum. Can tab, yes, pretty much. Module animate generic, we've already been through. FX module look at constraint. We're gonna completely ignore this module. It is pretty darn complicated, and it's to do with module animation effects, and yeah, really not for beginners. Leave it alone. Flag decal, pretty much self-explanatory, and we've already been through it. What else can we find? We can go through part configs for modules until the cows come home, because there's that many of them. So, most of the parameters that you're going to come across have been gone over in detail here. However, if you have a look in my profile, for those running on a PC or Mac, basically in a web browser, just scroll down the page and you'll see something like resources, common resources or something. And there is a list, there's a link in there to the part config wiki, and it is quite long and quite detailed. It is not, however, complete. This is a wiki that's been created by users and streamers and modders, and is not, I say again, not maintained by Squad. So that link down there, feel free to click on it, open it up and take a read. It's quite interesting. It will have more config parameters and explanation than I can possibly go through in an evening, basically. So I've just touched on the basics. So I've shown you that config files, CFG files, can be edited and easily changed without specialist software. Most of what's in the config is self-explanatory. Some things, if you don't know what it is, don't change it. Or at the very least, if you're gonna change a config file, I highly recommend making a backup copy of that config file before you change it. Or better yet, if you are editing stock config files, then I actually highly recommend that you don't do it on the only KSP install that you've got. I definitely recommend making a copy of it and experiment with part configs in the copy of the KSP install. Which I'm sure most people know how to do by now anyway. So that pretty much concludes the beginner's tutorial. So we're now going to switch to insane